Hello everyone. Now we are going to study the content of machine learning. Today we would like to talk with you about the Bayesian learning. So the 4.1 is Bayes theorem. The Bayes theorem is a fundamental series in probability series used to calculate posterior probability. It is based on prior probability and likelihood, calculated using the following formula. The state of the series is like this. Bayes theorem is stated mathematically as the following equation. And in this equation, where A and B are event and P is not equal to 0, PA over B is a conditional probability. The probability of event A occurring given the event B is true. It is also called the posterior probability of A given B. PB over A is also conditional probability. The probability of event B occurring given that A is true. It can also be interpreted as the likelihood of A given a fixed B because of B over A means L over LA over B. PA and PB are the probability of observing A and B respectively without any given conditions that are known as the prior probability and the marginal probability. The probability, the initial estimate of the probability of event A occurring without new data. Likelihood is the probability of event A occurring given that event A has occurred. Posterior probability is the probability of event A occurring after observation event B. Applications. Bayes theorem is widely used in statistical inference, classification problems in machine learning, parameter estimation, and more. The Naive-Bayes classifier. The Naive-Bayes classifier is a simple yet effective classification algorithm based on Bayes theorem. Its core assumption is the independence of features. The main steps include calculating prior probability, compute the prior probability of each class based on the training data, calculating conditional probability for each feature, compute the conditional probability under each class. Classification decision for a new sample, compute the posterior probability of each class and assign the sample to the class with the highest posterior probabilities. Advantages. The Naive-Bayes classifier is a simple, efficient, and suitable for tasks like text classification and span filtering. Disadvantage. Due to the independence assumption, performance may decrease when there is strong feature correlation. The Bayesian network. A Bayesian network is a direct acyclic graph, DAG, that represents random variables and their conditional dependencies. It consists of nodes and edges, where nodes represent random variables and edges represent conditional dependencies. Features and the construction model of Bayesian network included structured learning. Learn the structure of a Bayesian network from data using algorithms such as greedy algorithm and genetic algorithm. Parameter learning. Once the structure is determined, calculate the conditional probability distributions from the data. performing inference using the Bayesian network to calculate the posterior probability of certain variables. Applications. Bayesian networks are widely used in medical diagnosis, fault detections, speech recognition, and more. And 4.4 Bayesian inference. Bayesian inference is the method using Bayes theorems for parameter estimation and predictions. The key aspects include point estimation, estimate the specific value of parameters using methods such as maximum A posteriors, MAP, and Bayesian averaging. Interval estimation, estimate the range of parameters providing a confidence interval. Prediction, use the posteriors distribution to make predictions and calculate the distribution of new data. MCMC method, Markov chain Monte Carlo method, which sample from the posterior distribution by constructing a Markov chain, enabling Bayesian inference. Applications. Bayesian inference is widely used in financial risk analysis, engineering reliability analysis, marketing forecasting, and more. The 4.5 Bayesian optimization. Bayesian optimization is a method that optimizes black box functions by constructing a probability model often used for hyperparameter tuning in machine learning. The main steps include surrogate model. Construct a surrogate model, for example, Gaussian process, to approximate the target function. Acquisition function. Use an acquisition function, for example, expected improvement upper confidence bounded to select the next evaluation point. Evaluation and update. Evaluate the selected point and update the surrogate model. Iterative optimization. Repeat the process of selection, evaluation, and update until the optimal solution is found. Applications. Bayesian optimization excels in hyperparameter tuning, experimental design, industrial optimization, and more. So now I would like to explain this chapter by Chinese. 现在老师用中文来讲解这个贝叶斯学习的相关内容。那么第4章是有关贝叶斯学习的内容的讲解首先要跟各位讲解的是贝叶斯定理。贝叶斯定理是概率论中的一个基本定理，它用在计算后验的概率。那它是基于先验概率和似然函数，通过以下的公式计算后验的概率。那么以下就是这个方程式P A over B 就等于 P B over A 乘上 PA 再除以 P over B 那么所谓的先验概率是指说在没有新数据的情形之下，对事件 A 发生的初步估计。所谓的似然函数是指说在假设事件 A 发生的前提之下，事件 B 发生的几率。那后验概率就是在观察到事件 B 之后，然后事件 A 发生的几率。那么这个应用呢，贝叶斯定理它广泛的应用在统计的推断，那么机器学习中的分类问题、参数估计等的领域。再过来就是朴素贝叶斯分类器朴素贝叶斯分类器是一种基于贝叶斯定理的简单而有效的分类算法。它的核心假设是在特征之间是互相独立的。那它的主要的步骤包括第一个就是计算先验概率，那么根据训练数据计算来每一个类别的先验概率。 那么其次呢，这计算条件概率，根据对于每一个特征，我们计算在各个类别下的条件概率。那分类的决策是对于一个新鲜的样本，计算它在每个类别下的后验概率，把样本归类到后验概率的最大的类别。第四就是优势，就是素朴贝叶斯分类器的简单高效，它适用于在文本的分类垃圾邮件的过滤等等任务。它的劣势就是由于独立性的假设，在特征相关性较强的情形之下，它的性能可能会下降再过来就是贝叶斯的网络贝叶斯网络是一种表示随机变量跟它的条件依赖关系的有向无环图的 DAG， 它是由一个节点跟边来组成。那么其中的节点就代表随机的变量，边就代表各个条件的依赖关系。那贝叶斯网络的特点和构建方法包括，第一个就是结构学习。那通过数据学习贝叶斯网络的结论，可以用来采用弹性算法、遗传算法等等。其次是参数学习，在结构确定以后，我们利用数据计算各个条件概率的分布。再过来就是推理，就是通过贝叶斯网络来进行推断，来计算某些变数的后验概率。那么它的应用就是贝叶斯网络，它可以广泛的应用在医学的诊断、故障的诊断、语音识别这个领域其次我们要讨论就是贝叶斯的推断。那贝叶斯推断就是利用贝叶斯原理来进行参数估计和预测的一个方法。它的主要内容就包括一是点估计，就是估计参数的具体值常用的方法有最大后验估计 MAP 和贝叶斯平居。其次是区间估计，就是估计参数的范围，来提供它的一个置信区间。再过来是预测，就是利用后验分布来进行预测，计算新数据的分布。再过来是 MCMC 方法，就是利用马可夫链蒙蒂卡罗方法，来通过构建马可夫链，然后呢从后验分布中来采样，来实现贝叶斯的推断。那它的应用就是贝叶斯推断可以在金融风险分析、工程可靠性分析、市场预测等等方面有广泛的应用那么贝叶斯的优化，就是贝叶斯优化，它是一个通过构建概率的模型来优化黑函数的方法。那常常用在机器学习中的超参数的调优，其中的主要步骤包括一就是代理模型，就构建一个代理模型，例如用高斯过程来近似目标函数。其次是选择的函数，就利用选择函数，例如说期望改进、自信上界等来选择下一个评估点。再过来是评估跟更新，在选择的点进行评估，并且更新这个代理模型。其次是迭代的优化，我们不断的重复选择、更新跟评估的过程一直到找到最佳的解。那它的应用就是贝叶斯优化在超参数调优、实验设计跟工业优化等方面，它的表现是非常的出色的那么我们今天的这个第4章的讲解跟各位就讲述到这边，谢谢各位的收听